Hello everybody, welcome back. We're going to have to say farewell to the 2003 Pascal in a moment, because we're on the very last question, question number 25. So hopefully you've enjoyed this contest as much as I have, and yeah, let's just get right into it with question number 25. Question 25, in the cube shown, L and K are midpoints of adjacent edges, AD and AB specifically. So K is in the middle of AB and L is in the middle of AD. The perpendicular distance from F, which is all the way down here, to the line segment LK. Okay, so perpendicular distance, that means it's going to make a right angle here. And it should probably, just based on where F is, and this is a good idea if you can bring like little wooden props with you. A little wooden cube is not that hard to find. You can find it at a craft store. And if you take a look at it, I'm pretty sure F is equally spaced between L and K. If you look at it dead on from F's point of view, so it should hit right in the middle. Right in the middle. So the perpendicular distance from F to the line LK is 10. What's the volume of the cube to the nearest integer? Okay. So first things to note, to the nearest integer, I'm probably going to want my calculator for this. Okay, that's usually the only time you really need a calculator is to the nearest integer, because you need to get a decimal expansion. Okay, not always, but if you wanted a decimal expansion of some really weird cubed root, it's much easier to grab down your calculator than to work out cube roots by hand. So to the nearest integer, you almost certainly want to have brought your calculator for that. Other thing I'm noting, we're asked for volume of the cube. So I start thinking in my head, okay, how do I find volumes of cubes? Just like I might ask, how do I find volumes of spheres or cylinders or tetrahedra? And for the volume of a cube, there's really only sort of the one formula. It's the same formula you would use for a rectangular prism. It's length times width times height, but on a cube, all of those values are the same. So if we just pick one of the side lengths, AB for example, or GF, really any of them will work, and we cube that, we'll be able to get our final answer. Because it'll be, let's call it, say, X or S for side length, or A, or whatever we want. A cubed would then be volume, because A is both the length, the width, and the height. So A times A times A gives us the volume of the cube. So immediately I might want to say, let the side length of the cube be some variable. Let's say A. Okay? So that's the first thing I'm going to do. I'm going to redraw my picture, and I'm going to first flip the page, but I'm going to label that side length. Because once I have that side length, and maybe as we go through the question, we'll find a better way to get the volume of the cube, a more specific way. But until we do, trying to figure out that A is a great way to break this down into steps. Once I have A, I'll be able to work out the volume. Yeah, that's a pretty good cube there. A, B, D, F. I think this one was G, and this is E. Right? Yeah, and C is here in the foreground. H would be all the way back here. Okay. And we've got K and L. I'm going to distinguish them and their line with a particular color, so it stands out a bit more. K and L. And we're talking about the perpendicular distance. That's something we've been given, so we go from F, and I said that should split it right in half. So this distance here. And it's perpendicular. It makes a right angle if you consider them all to sort of be on the same flat plane, which can be hard to visualize. You'll find oftentimes that a three-dimensional question is one of the last questions because it's something that's not particularly gone over in school, and it's something that people have a very hard time working with because you're stuck writing on paper for the most part. Most people don't bring in props. Some proctors don't even allow props, so always check whether or not you don't want to pull out a prop and have your paper be confiscated because you didn't check with your proctor ahead of time, the person who's overseeing the exam. But if you're working on paper, it's very hard to think about 3D objects. And so a three-dimensional question, just by being 3D, it makes it that little bit harder. Okay? So you'll find this happens a fair bit. Okay, so we've got a length of 10 here. And, I gotta go back to the red. So we've got 10 here. And I'm going to say this distance here is A. Okay, now what were we told? I think K and L are midpoints, aren't they? K and L are midpoints. So, immediately I can say A to K, why that's A by 2. Same with A to L. And cubes have right angles, so I know this distance here, this right angle, this triangle here. If we just look at it flat, if we just look at it top down, A is over here, we've got A by 2 and A by 2, we've got a right angle here, and we've got K and L. If we just look at this triangle like this, looks like we've got Pythagoras. So KL squared is the same as A by 2 squared plus A by 2 squared. And that's going to be A squared by 4 plus A squared by 4. And that's going to be 2A squared by 4, or A squared over 2. So KL, the blue length, the one that we have distinguished, I can already say that that's the square root of A squared over 2, or A over root 2. Okay, if you wanted to rationalize the denominator, you could also say root 2A over 2. I don't think that's necessary right now. So whatever that is, I can say that this whole side length here is A by 2. Okay. What else can we do? I'd like to be able to relate this to the 10 somehow. So what I'm going to do is I'm going to, in green, draw a little bit of a triangle. I've got a right angle triangle here, because we were told specifically perpendicular. So we now have a triangle. And, oops, wrong button. We want that over there. And our red here. Okay, we have a right angle here. We know that this is a half of the whole blue length, which is A over root 2. So this is A over 2 root 2. We know the red is 10, and the green is, I don't know, but we've got a right angle. They specifically told us perpendicular. So how about we work this out? Our question mark squared is 10 squared plus A over 2 root 2 all squared. So that's 100 plus A squared. What's 2 root 2 squared? Well, that's 8. So we have 100 plus A squared over 8 is our little question mark squared. Okay. So we could probably get a nice formula for question mark by square rooting this, but I think that's kind of ugly. If we really want to, yes. This side length is square root of 100 plus A squared by 8. But in that form, there's nothing I can really do with it. Okay. So that completes this, this triangle here. Ultimately, we want A. So maybe it's a good idea to get some of these lengths in a different way. I can't get the red 10 a different way because he sort of stops, and there's not another nice way to calculate him. But I can get the green line another way. The green line should be this length squared, plus this length squared. That should be the green length squared. Well, this is A, and this is A, and this is A by 2. So I know that this is a sort of an application of multiple Pythagoras theorems. Okay. If I have the green dashed line going from DF, so this is F up here. This is some midpoint. Let's call it J. This is J here. And this is L. So LF is 100 plus A squared over 8. Square root of that. Okay. Now, there's another way to calculate LF squared is also DL squared plus DF squared. but that's a by 2 squared plus df squared. And there's another way to calculate df squared. That would be dg squared plus gf squared. So LF squared, which is 100 plus a squared over 8. That's LF squared. But that's DL squared plus DG squared plus GF squared. And that's a by 2 all squared plus a squared plus a squared. So that's a squared over 4 plus 4a squared over 4. Getting a common denominator here. And we've got 9a squared over 4. And that's the same as 100 plus a squared over 8. Okay, well, now let's just put these two together. And we should solve for a, and then we can cube it. So multiply through by 8 on both sides. That'll get rid of this base of 8 and this base of 4. So we'll have 800 plus a squared is 9, but there's also a 2 left over, so it should be 18a squared. So 800 is, bring one of the a squareds over, 17a squared. A squared is 800 over 17. So a is the square root of 800 over 17. Now the volume is a cubed. So that should be square root of 800 over 17, all cubed. And this is certainly not a number I can work out very easily. So this is where I grab my calculator. Okay. 800 divided by 17. And then square root of that. I'm getting about 6.85. And now I want to raise that to the power 3. I'm looking, do I have a button for that on my calculator? Yeah, raise that to the power 3. And I'm getting 322.8208662. Okay, now I'm going to do that calculation again. Always a good idea to double check, make sure you haven't hit a button. So 800 divided by 17, that's about 47.05. Now I'm going to square root that, 6.859 something or other. Sure, and now raise that to the power 3. I still get 322.82, etc. So now, let's see. That, to the nearest integer, that would be 323, because we round up because of the 0.8. And 323 is exactly one of the answers. So we're looking at A. Okay. So very nice indeed. Not that difficult a question, I would say. Certainly conceptually, it was mostly fine. I think the biggest thing there was probably connecting up L and F to make that triangle. And then realizing you can calculate the length LF in 2 different ways, thanks to the given information of the perpendicular distance from F to LK being 10. That made a right angle, so there was a way to calculate LF squared one way. And then using the typical sort of repeated Pythagoras, FG squared plus GD squared plus DL squared gave us another way to calculate LF squared. Equating those two, we were able to solve for A, and from there we get the volume of the cube, and we're done. And in fact, we're truly done because we're done this contest. So the next multiple choice contest I'm going to go through is the next year, so the Cayley 2003, so we're going up a year to the grade 10 contest. Also in 2003, they started doing the written contests. So the Friar Galway Hypatia, the grade 9 version of that is the Friar, so you can look forward to that. And also, if you just really want to keep practicing Pascals, the 2004 Pascal should be coming up as well. So, whatever you want to join me for next time, I can't wait to see you, and I can't wait to do more math. So, thanks for watching. I'll see you guys next time.